Hi everyone, thank you for joining me in this Excel session for how to do the calculations in Excel for experiment 8, determining the pKa of a weak acid. We're going to start by inserting the following information into cell A1. We're going to write NaOH concentration in molarity from week 1 experiment. We're going to wrap that text to make it look pretty. And then you're going to insert your information that you gathered. So mine was 0.1989. You put in whatever you had. In cell A2, we're going to put volume of acid solution in liters. And if you remember, you dissolved your weak acid unknown in 50 mils of DI water. If you did not do 50 mils of DI water, make sure to write down the actual volume that you put. So 50 mils is 0.05 liters. Alright, in cell C1 we're going to write mass of HA used in grams, and this is where you're going to write the mass of your acid that you measured out. So my value is 0.5349, but you're going to put in whatever value you have there. Next, you're going to copy your raw data. I'm going to copy mine over here from another screen. So you're going to copy down from your notebook your burette reading as well as the corresponding pH. If you have not done this yet, go ahead and pause this video. Great, you've copied down your information. Awesome, we're ready to go. So we're going to actually move the pH information. So in order to select just this data, you do Control-Shift down, and you can do cut, and let's paste it into E3 for now, because we're going to put some other stuff in between here. So we're going to figure out the volume of NaOH added in mils. We're going to figure out that volume of NaOH added in liters, and we're going to do some other stuff in a second here. So, in order to figure out the volume of sodium hydroxide that you added, initially at your first burette reading there's no sodium hydroxide, so you're going to put a 0 there. For the equation to figure out the volume from your burette readings is you take your corresponding reading in cell A5 minus your initial reading. You're going to lock that initial reading by putting a $sign in between the letter and the number, and that's going to keep that initial value there. And then you're going to populate this equation all the way down by double-clicking or dragging. And so if we double-click on one of these values, we can see that we're taking the value that we are currently on minus your initial value. Okay, so now to figure out the volume that you added in liters, you just convert mils to liters. So you take your mils, you divide that by 1,000, and that's your liters. And then you populate that all the way down. You can, it doesn't like that. You can double click to make sure that your equation still holds true. Alright, so now before we move forward, we're going to make a titration curve. So we're going to take the volume of sodium hydroxide, we're going to select that by doing Control-Shift down, hold down Control, and you're going to select your pH values as well. And then you're going to go to Insert Scatter Plot, and you're going to have a graph that looks like this. You're going to cut this, move it to a different page. That way it's out of the way of all of your data. Then you're going to make it nice and big. So now you want to try to find your equivalence point. So your equivalence point is going to be at a pH near 7 in the middle of the horizontal section of your graph here. And so let's zoom in a little bit more. So you should have a significant number of data points in here. If you don't, then your data is going to be a little bit off, but it should be counteracted by doing the actual calculation. Right now, we're going to find the rough value of the pKa, but first we need the equivalence point. So you want to see what value has the largest pH change, with the smallest amount of sodium hydroxide added. So here we have 14.65 mils at a pH of 8. And then if you add 0.03 mils, it increases by 0.82 pH units. But if you see that you move up more, if we add 0.06 or 0.06 mils, it goes up by 0.6 pH units. So this one has the most drastic change. So we're going to assume that this point here is my equivalence point. So go ahead and pause the video and find the equivalence point in your graph. Now that you've found the equivalence point in your graph, before we forget the value, we're going to go back to our data and we're going to highlight the 14.65 mils. So I'm going to find that. I'm going to highlight that. All right. So now that we've highlighted that, that's our equivalence point. So to find the pH at half the equivalence point, what's half of 14.65 in mils? So for me, that's going to be about 7.3 or 7.4. So we have 7.55. That's pretty close. So this is going to be our half equivalence point. So you're going to highlight that all the way across. All right. Awesome. So now that you have found, so this value here, and you can even write this up here. You can say pH at half equivalence point, and we're going to say 7.55, and this is your graphically determined value. So let's highlight this in yellow for now. Okay, and let's put a border around it. I like borders. So we're gonna do all borders, line style. Let's do this one. Click that again to get that to solidify. And I'm just gonna add a bunch of borders right now because I like to keep things nice and organized. All right, I'm also gonna change the font of everything while I'm at it to Calibri Light. All right, cool. So let's consult our handy dandy lab manual here. So it says plot the titration curves for the unknown acid for your 2 trials. Cool, we already plotted for a trial. From these graphs, graphically determine the volume of NaOH needed to reach the equivalence point. So we have highlighted that. Use this to calculate the number of moles of NaOH needed to reach the equivalence point. So let's find that next. Let's find the moles. So now that we have our volume, we can find the moles because we have our concentration. So moles of NaOH added. So we're not just going to find them just at the equivalence point. We're going to find them at every given point in time because we're going to need this information later. So the way we find the moles, if we have a volume and a concentration, we multiply the volume times the concentration. The concentration is not going to change, so we're going to lock that down by putting a $sign there. And then you're going to populate that all the way down. All right. So I'm actually going to move the pH one more over. So we're going to select that by doing our Control-Shift down. We're going to paste it over here. Because what I want to put over here is I want to put the total volume of solution. I'm going to show you why we're doing this a little bit later. So the total volume of the solution, where do we have volume here? We have the volume of the acid solution, so that's never going to change, right? Because you put that in initially. So we're going to lock that down. And then you have the volume of sodium hydroxide that you've added up to that point. And then you're going to populate that all the way down. I'm going to change my font here. Okay. So, and we're going to say this is in liters. Alright, so let's go back to our lab manual and see what we need to do next. So, you want to calculate the molecular weight of the unknown acid. So let's go ahead and take a little segue and do that real quick. Let's figure out the molecular weight of your acid. So, we're going to label this up here, molecular weight of acid. I'll show you why in a second. So, in order to figure out the molecular weight of your acid, you know that, let's see, volume of NaOH added at the equivalence point you can determine this, right? Because you've experimentally determined this. You know the moles of NaOH at the equivalence point. And what do you know about the moles of base at the equivalence point and the moles of acid? They are the same. So, volume of NaOH out of the equivalence point. Let's go down here. Here's our equivalence point. Volume. Let's do everything in liters here. So we're going to copy this value. That's our volume. And we're going to paste only the values. And then the moles of NaOH at the equivalence point, we're going to copy that, paste only the values. And the moles of acid at the equivalence point is the same. So we're going to say is equal to this. Okay? All right. So if you have moles of acid and the mass of acid that you used, you can find the molecular weight. Molecular weight of HA in grams per mole. So you simply take your grams divided by your moles. And this here is your molecular weight of your acid. So you're going to need this later. So we're just following the lab manual right now. I'm going to merge this. I'm going to do some formatting here. And I'm going to make this a different color. I'm going to color this a light orange. Okay. Let's see what else we have to do now. Alright. So we determined the equivalence point. And I want you guys to draw a vertical line from the equivalence point to the x-axis, and then I want you to draw a vertical line from the curve, right, for 1/2 of that value. So I'm going to let you guys draw that in Word with a drawing tool. So we'll get back to this a little bit later. So now we figured out the pKa by looking at the graph. So now we're going to calculate the pKa by using all of the information that we have from our graph. So this is what we're going to be doing at the end, but first we need the H+, the A-, and the HA. So step 1 is figuring out the H+ concentration. Well, this is the easiest step. You can figure it out from the pH because it's 10 to the negative pH value. So let's do that. You know what I'm going to do? I'm going to take our pH value and I'm going to move it one more time. No, actually I'm not going to move it. Just kidding. I'm going to insert a column here. I'm going to not fill that. So we're going to say H plus concentration. So this is equal to 10 to the negative pH value. Simple as that. And then you're going to populate that all the way down. So this is cool. We got one step down, pretty easy. I'm going to highlight all the pH values in green here, the H plus stuff. Okay, so that's the H plus. Now what else do we need? Let's follow the directions. Determine the A minus concentration. So the A minus comes from two sources. The amount of the HA that dissociates when dissolved in water, and the amount that reacts with the hydroxide. Okay, so the first source can be found from this equation, and you can see that if you were to look at the equilibrium expression, you can see that this is equal to the H plus concentration. So the first source, A minus 1, is equal to the H plus. So let's go ahead and do a column for that. So we're going to say A minus 1, and let's color these a sky blue, why not? And we're just going to say equals this value here to make it easy on ourselves, and then bring that all the way down. I'm going to change my font here. Cool. Change that color. Let's also make some borders on it. Sweet. Okay. What about A minus 2? Let's consult our lab manual again. A minus 2 can be determined by the OH concentration. It's equal to whatever concentration of sodium hydroxide that you have. Moles of OH added divided by total volume, so that's the same as the sodium hydroxide concentration. This is why we put in the total volume column earlier. So we just need the moles of OH, which we already found, divided by the total volume, and that's your A2. So, equals moles of OH divided by total volume. Populate that down, do some formatting. You're golden. Alright. And then your total A minus concentration is going to be given just by the sum of these two columns here. And then you populate that down. Alright, so you have your H plus, you have your A minus. Now let's see what else you need. Determine the HA. To find the moles of HA, you take the initial moles and then you subtract the moles that reacted with your base, with your total base. So essentially what you're doing is you're figuring out the concentration of your acid at a given point in time, but you're subtracting the amount that was reacted. So you need the mass of the acid that you had and the molecular weight. So if you take your mass divided by your molecular weight, you just get moles. And moles divided by volume is concentration. So you have a concentration minus a concentration. That's giving you your HA concentration. So let's put this into Excel. So the mass of your acid divided by your molecular weight. So your mass of your acid never changed. So you select that and you lock it down. We need parentheses here. Divided by your molecular weight, and that's also not going to change as you go down the column, so you have to lock that down. and then you divide that by your total volume, but you're dividing all of this, or rather, I'm sorry, you're subtracting something from all of this. So all of this needs to go in parentheses, minus your A minus total. And that's going to be the concentration of your acid at a given point in time. Okay. Formatting, make it pretty. Cool beans. So now we have all of that stuff. Once you have all of this stuff, you can solve for your Ka and your pKa. So from up here, the Ka is just H plus times your A minus divided by your HA. So we're going to find the Kas first. Now, I'm going to do the Kas for every data point, but we don't need them for every data point. But just for simplicity's sake, I'm just going to do that first, and I'll show you why in a second. So Ka, this is equal to your H plus times total A minus divided by your HA, and that's your Ka. You're going to populate that down. And we're going to format again. It's kind of weird that it doesn't remember that. So we're going to have our pKa over here, and if you remember, your pKa is just your negative log of your Ka. Populate that down. Format, 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 bam. But wait, we've got 5 million pKa's, bro. Bro, we don't have numbers down here, bro. But that's okay. Let's read the directions from the lab again, shall we? It says that you should do this calculation with 4 to 5 values near the half equivalence point. You must take at least some data from both of your trials, and you must use at least 8 different data points to calculate your pKa. So what we're going to do is we're going to find a total of 5 values from each trial. So see how this is still in yellow? That's for a reason. So this is your half equivalence point. So what you're now going to do is you're going to highlight the 2 above that point, the 2 below that point. Let's highlight all of these in yellow now. These are now your pKa values that you're going to be using for your average for this trial. So I recommend doing a Q test to see which of these points can be removed from this average so you can get the best average possible. So you'll be taking 4 or 5 data points from each of your trials to figure out your pKa. And see, the reason why we do this experimentally is because if you look at these values, it looks like the average is going to be about 4.15. And what did we find over here? pH at half equivalence point. Oh, I don't know why. I'm sorry, I put 7.55. This is actually the mils. I should have actually put 4.18. 4.18. There we go. Sorry about that. If you were following along early and you realized I made a mistake, sorry about that. This is why I kept you watching the whole video. No, I'm just kidding. You chose to do that of your own volition. So we have 4.18 over here, which is pretty close to these values. You know, it's pretty close. Looks like the average will be about 4.14, 4.15. But you do this for both of your trials. So this one is trial 1. This one, so I want you to have a unique title. Please look at the guidelines I posted online for you. But for the purposes here only, it's saying trial 1 titration curve. Is this a good title? No, it's a terrible title. Do not title it like that or I will take off points. I'm just going to say graphs over here. So make sure that you stay organized. That's a very important part of doing all these calculations. In any case, there you go. That's how you do the math. I hope you've had a great time. If you have any questions, please send me an email. Let me know. Also, please send me feedback on what you thought of this video. I would greatly appreciate that. Thank you guys so much. I hope you have a wonderful day. Ciao! Whoop!